Today we're talking about how modern scientists modify Arrhenius's acid-base definitions. We're doing this so we can more accurately predict if a chemical is an acid or a base, and our success criteria is being able to describe these modified definitions. So in 1956, Paul Giguère, a Canadian scientist, and Mark Fulk discovered the hydronium ion. Now, the hydronium ion was something that had been theorized to exist, but at the time, a lot of chemists thought that it would be too unstable and would just disappear super quickly. But in reality, hydronium ions are actually super common. So what hydronium is it's the combination of a hydrogen ion with a water molecule. Its formula is H3O+. And it turns out that these hydronium ions are actually responsible for the acidic nature of compounds that are acids. So what's going on here? Well, the revised definitions of Arrhenius' theories we use take into account both of the facts we just talked about, although we glossed over them super quickly. One is that collisions of substances are happening with the water molecules in solution all the time. And we know that when two substances collide, there's the possibility of a reaction taking place. And then the other is the nature of the hydrogen ion. When the hydrogen ion dissolves in water, it actually doesn't dissolve. It never ends up as a lone hydrogen ion in a solution. It actually gets transferred straight from the acid to the water molecule. So acids and bases have to be in aqueous solutions. So the particles of the acid and the base are going to be colliding with the water around them all the time. So when a chemical is acidic, it's the result of a collision between the acid and the water molecule. During that collision, acids are transferring their hydrogen ions over, which means they're going to react with the water molecule to produce a hydronium ion. And bases, then, they can do the same sort of thing. They just do it in reverse. They can actually receive a hydrogen ion, and the water turns into a hydroxide ion. And as well, bases can just straight up dissolve in water too, if it directly contains a hydroxide ion already. So these are the modified Arrhenius definitions that are closer to what modern scientists use. There's still a little bit more refinement that most acid-base chemists use, but for Chemistry 20, this is how we're going to define acids and bases.